guys, let's do another Inelastic Collisions problem. A 910 kilogram sports car collides into the rear end of a 2200 kilogram SUV stopped at a red light. The bumpers lock, the brakes are locked, and the two cars skid forward 2.7 meters before stopping. The police officer, knowing that the coefficient of kinetic friction between tires and road is 0.80, calculates the speed of the sports car at impact. What was that speed? Okay, so in the previous videos, you've seen a two-stage process, before and an after, when we do our conservation of momentum. This problem actually has three things going on. Okay, initially you've got the sports car driving forward, and the SUV is just parked, right? So here's your sports car, it's moving, but the SUV is not. In the second instance, you've got the two colliding. So you've got these two touching each other. And then once they hit each other, they start moving forward. Well, rather, they start skidding forward until they come to a stop. So we've actually got three parts to this problem. And we're going to be using all three parts to solve it. So there we go. Okay, so let's start identifying what we're given in the problem. We're given mass of A. So we'll call the sports car A. We'll call the SUV B. So here we go, A and B, A and B. Mass of A is 910 kilograms. V1A, the initial speed of A, that's what we're looking for. We don't know what it is. Mass of B is the car, the SUV, 2,200 kilograms. And the initial speed of B is 0 because it's at rest, it's at the red light. Okay, so now in scenario number 2, they're stuck together, they're moving forward. So collectively they have mass MA plus MB, and they're moving with speed V2AB. And finally, they're skidding forward until they come to a stop. So V3AB is 0. Okay, so we're told that. So what we don't know is the V2AB, and which leads us to get the V1A. That's what we need. Okay, and over this distance, the cars travel 2.7 meters. And we're also told the coefficient of kinetic friction between the tires and the road is 0.80. So all of these are different stages in the problem. So we'll call this 1. This is 2, and that's 3. So this is how you should think about this problem, okay? In order to find V1A, look, I've got MA, MB, V1B, MA plus MB, whatever, I can find that. But I need V2AB in order to finish this. But I have two unknowns right now. So what I need to do is find V2AB through a different means. So I'm going to then look at this part of the problem, parts 2 and 3. Okay, so I've got an object of mass MA plus MB moving forward. Its final speed is 0. There's the coefficient of kinetic friction. Therefore, it's accelerating in the negative direction. It covers this distance. I've got two speeds, one unknown, one known. I can find the unknown speed. Okay. So in order to do that, I'm going to use Newton's second law. Okay. So first things first, do your free body diagram of what's happening in this situation. So this is going to be A plus B. Now A plus B, you've got the normal force acting on them going up. You've got the gravitational force going down, and you've got friction going to the left. So force of friction. And that's it. That's why it's slowing down, right? Because your force is to the left. And we'll assign our positive x direction to be to the right. Okay, so let's go ahead and do our Newton's second law. F net equals ma. Okay, my net force is friction, but it's going in the negative direction. So minus force of friction equals ma. Friction is just the coefficient of friction times the normal force. And in this case, the normal force and the gravitational force are the only two vertical forces. So they are equal in magnitude, opposite in direction. So I can just sub mg for Fn. So doing that allows me to cancel out the masses. And so you can calculate your acceleration as minus mu k times mg. So minus 0.80 times g, meters per second squared. And when you do that, you're going to get your acceleration to be minus 7.84 meters per second squared. Okay, so I've got acceleration, distance, final speed. I can find initial speed. It's very simple at this point. Okay, so I'm going to use this formula. Hopefully it looks familiar. 2AD equals V final squared minus V initial squared. So in this case, V final is V3AB and V initial is V2AB. Okay, normally it's V2 squared minus V1 squared. Now, V3AB is 0, so that's awesome. That just disappears. So 2a delta D equals minus V2AB squared. That's what I'm looking for. Okay, so I'm going to rewrite this as V2AB squared equals negative 2. So I just brought the negative to the other side. Or if you want to look at it like this, divide both sides by negative 1 equals negative 2 times the acceleration, negative 7.84 meter per second squared, times the displacement, 2.7 meters. Sorry there, I'm running out of room. That's 2.7 meters there. When you plug that into your calculator, you are going to get the V2AB squared is 42.336 meters per second. So that's meters squared per second squared. And take the square root of that to get V2AB, and you're going to have about 6.51 meters per second. So we have now found this value, so that's good. We can now work backwards and figure out the initial speed. And to do that, we're going to use conservation of momentum. So you've got our V2AB, so now let's do P1 equals P2. Okay, so initially the only object that has momentum is A, the sports car. So it's going to be MA V1A equals MA plus MB are moving at V2AB. Okay, we're trying to solve for V1A, right? So we're going to isolate for that. V1A equals MA plus MB brackets 2AB over MA. So at this point, you just have to plug in your values and crunch the numbers. So MA is 910 kilograms. MB is 2,200 kilograms. Add those two together. Then multiply by 6.51 meters per second and divide by 910 kilograms. And when you punch those in your calculator, you're going to get your V1A to be 22 meters per second. And that is accurate to the right number of sig figs, which is 2. So there is the speed of the sports car on impact. So that's it for this video, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned next week for video 128 to be posted at 12 noon. What? Wait, who's back to school? Pumpkin pie recipe. Okay, I'll save that for Halloween. Guys, so that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. Guys, as always, if you missed my videos from the past, be sure to click over there on the right. You'll see some of my latest videos there. And other than that, guys, I hope you enjoy the rest of your day. Peace.